Well, good morning, good afternoon, good evening, everyone. My name is Mark O'Brien. I'm a director at CM First, and I want to welcome all of you attendees to today's webcast, which is basically going to be showing you CM Evolve IT, one of our family of product solutions, and COBOL, the Java conversion, converting legacy languages to modern ones. It's Halloween. And happy Halloween to everyone, and we be a nice treat for everybody. As you know, if you've been on any of our webcasts before, we always start off with an audience poll. So the first poll question today is going to be, which legacy languages is your organization looking at replacing? So the options are COBOL, RPG, CA2E or sign-on, CA Plex, CA Gen, all software modeling tools, not part of Broadcom, Visual Basic, C or C++, or other. So overwhelmingly, people looking at replacing sign-on, Plex, or Gen, software modeling languages, followed by COBOL at 33%, RPG at about a quarter, and 8% for either Visual Basic C or C++. So I'm on the left there, I'm Director of Business Development, and I'm joined today by John Rhodes, who's our Chief Technical Officer at CM First, and Kiyoshi Terasawa, who's a Principal Architect at CM First. We've got a lot of ground to cover here. Technically, it's going to be technical in nature, and basically the flow of the presentation is going to look like this. The solution with our family of CM Evolve IT, this is called Meta TX, COBOL to Java conversion, and we'll start off with John will do a technology introduction, followed by Kiyoshi and a live demo, and then we'll have time left over for doing Q&A. So at this point, I'd like to turn the presentation over to John, who will enlighten you with some of the technical details about this breakthrough.
All right, thank you, Mark. So I'm John Rhodes, CTO here at CM First. I'm going to go through an introduction to our technology around transforming legacy code from, in this case, focused on COBOL to Java. But as a company, we focus on a lot of legacy languages, especially on the IBM I platform, or AS400, and also on the IBM Z. Okay, so keeping with the Halloween theme here, what is it keeps application managers up at night? Well, that's probably quite a few things that scares folks. I know it's not just one, but I think increasingly we're hearing about this one here, which is, boy, my staff is retiring. They're retiring this year, they're retiring next year, and I really have a hard time finding anybody to do the job in legacy languages like COBOL. I mean, COBOL came out over 60 years ago now, and so that means the people that started out with COBOL when it was a brand new language are really reaching their retirement age, and people are not learning COBOL in school. When I started college some years ago, I didn't learn COBOL. I thought COBOL was dead, but I'm wrong about that. But it is slowly fading out over time. So people might be aware that Amazon is discussed about different modernization pathways for legacy applications. And they have 5. Some people say 6. Some people say 7 even. But I'm going to go through and stick with 5 here. First couple are rehosting and replatforming. So that might be taking your COBOL code or whatever code it is and doing a lift and shift in the case of rehost. I'm going to lift it. I'm going to run it as COBOL. I've seen some approaches where the COBOL is actually cross-compiled to a bytecode, VM bytecode, and runs kind of as a job application. But the first 2 cases, we're talking about maintaining the legacy language, COBOL, for example, and just moving it to a different platform. So yeah, you've maybe saved on some costs of running on the IBM or costs of running on the mainframe, and you're on a cloud platform that certainly is a better way or the future, but you're still left with your COBOL code, right? So you still have to maintain staff in COBOL, and you got to keep your COBOL skills up, and you'll be, so that is not really the solution that most people want over time. So we're going to not talk about options 1 and 2 in this presentation. And also we have the last option, which is always there, keep the application running as is, or retire it, maybe replace it with a package or whatever. So I'm also going to take 5 off the table for the purpose of this presentation and focus on options 3 and 4. So refactoring the COBOL to a modern language like Java, and at the same time doing some re-architecture. So enabling the COBOL to be transformed to Java and then called as a microservice through various standard techniques, including Spring Boot. And that's the part we're going to focus on the presentation today is 3 and 4, and we're going to do some live demos. Kiyoshi will be doing that a bit later in the presentation. Okay. And in today's presentation, we're going to focus on using automation to accomplish the refactoring and the re-architecting. And I think automation has several advantages. I'm going to focus on 3 of them. Primarily, it's a way to reduce the cost, time, and risk of your refactoring project. I think in days past, certainly, people would bring in a large team of developers, and they still do, and just rewrite the application by brute force. And that can work, but most times it doesn't meet the requirements, in that it goes over budget, over time. It takes years, and it's very risky too. You have the risk that the development team may not understand requirements or may not understand the existing application well enough to implement the new one. They miss something. In almost all cases, it just takes a lot more time and money than people think it does. So with automation, you can reduce that to take it down from a several year time frame to something that's in the weeks and months. Okay. Another thing is that since you're retaining aspects of the existing application, you can minimize your end user retraining time. Yeah, you'll have a new screen, you'll have a new way to get to your information, but it's going to be the same application, same business rules. And lastly, you can utilize your existing staff. I know a lot of people want to keep their development staff in place, so you can take your COBOL staff, retrain them in Java, or at least have them there as business analysts, because they understand the application. They can go in, maybe help the Java team understand, and even if they get up to speed, maintain the application themselves. So here's three advantages of using automation, which we'll be focused on today. Okay, I talked about manual projects failing. That's certainly a case, but a lot of automated software refactoring projects also fail. And I wanted to kind of go into some of the reasons behind that we see anyway. And it's around insufficient. 4 things that really come up all the time. Insufficient analysis. Maybe the automation works for transforming pieces of the application, but you've forgotten about the interfaces, or you've forgotten about code that can't be automatically transformed, maybe in a different language than COBOL. So the analysis part is critical to do that up front. Also insufficient automation. So a lot of folks think that, well, if I can get something that's 90% there, I can just do the 10% by brute force. And the problem with that is that 10% can be 90% of the effort. Finding out where the problem is, where it didn't automatically come across as one part of it, and then fixing it can be also very difficult. So we believe that highly automated is the way to go on this type of transformation. The third thing is the result may not fit architectural standards and may not be maintainable. We've all heard the infamous COBOL result, where you've taken COBOL and you've produced something in Java that runs, but it's it's just not very maintainable by the existing COBOL programmers or the new Java programmers. Or it may not even fit in standard architecture. There may be some odd run times or performance issues around the way it was implemented. And lastly, I think it's not having to focus on DevOps and testing as part of the process. We're not going to talk about that much today, but that really is a critical piece of any software project, and we recommend that as part of an automated refactoring. Okay, so now I'll talk about our technology around automated refactoring. It's called CM Evolve IT, and a new capability, MetaTX, the transformation capability. So CM Evolve IT has been around for quite a while. And it really has an excellent automated analysis capability with can parse COBOL, can parse 2E, and a lot of other languages to talk about, and bring those into a meta model that can then be analyzed. So the first part of your project, analyze, is kind of built into CM Evolve IT. Second is it's highly automated. Okay, so the transformation parts of CM Evolve IT work at 100% automation. Now, maybe not at first. Maybe we have to train the automation to work with your specific code base, but in the end, we have something that is highly automated, and that way you don't have to worry about your developers spending a lot of time going in and debugging the results or changing the results. It's going to work out of the box. So that's really a key thing there. It does run within a standard architecture, and it is maintainable. It may not be the Java that you would write by hand, but it's certainly standard Java that can be maintained within Eclipse or your other Java development tools. And it runs in a standard architecture using Spring Boot, etc. And the result also fits into standard DevOps pipelines. Okay, so let's dig a little bit deeper into CM Evolve IT. Okay, so this product works by first parsing code bases. Okay, so they can be in a variety of different languages. We'll focus on COBOL today, but it also can parse RPG, JCL, CL, everything that kind of runs on the IBM I platform or IBM Z platform is likely supported. We also support several map models, including CA2E or Sign-On, CA-Plex, CA-Gen, Lanza. Okay, so we take the source in, we parse it, put it into a big data repository, and then allow you to do analysis. And we'll touch on some analysis in the demonstration a bit later. But then once that's in this big data database, it can also be forward transformed. Okay, so we can take the results. We have a rule compiler that has transformation rules, especially trained to COBOL. Okay, and those rules are used to transform and format the COBOL so it goes into a standard Java format, and it's very maintainable, as you'll see in the demonstration, with an exposed API that can be called with the Spring Boot process. Okay, so I'm going to set up the demo scenario a bit, and then I'm going to turn things over to Kiyoshi to show this running live. Okay, so here's the demo scenario we're going to talk about here today. And we're going to look at an AS400 application in this case. And an application that was written in COBOL partially and also partially generated by CA2E. Okay, so we'll look at several programs that are implemented in COBOL, running on green screen, okay, a very monolithic, typical IBM I architecture. Okay, so this COBOL code has a 5250 interface, and it's accessing DB2 on the back end using DDS file access techniques. Okay, and then we're going to look at our desired architecture, which I think is pretty standard what people want these days. Okay, and that would be transforming the COBOL into Java that runs under Spring Boot. Okay, so and accessed by an API. In this case, we've also transformed the database to Postgres. Okay, and then we have a web UI set up to call the APIs that have been exposed in React, and that's a standard standard user interface that can be reformatted and run on basically any form factor, that be a phone, a tablet, or a PC with a large monitor. Okay, so in the demonstration, we'll talk about analyzing and selecting the slice of code to modernize, how we model the target architecture in SIEM Evolve IT, and then how we transform it and test it. Okay, so I'm not going to talk a lot about that. We're not going to do a lot of demo of the analysis, but we do, again, have an analysis capability called SIEM Evolve IT that lets you go in and look at your code, find the fracture planes or application subsystems and other interfaces to external systems, find those and categorize those. You can go in, you can drill into areas of complexity. We have code metrics built in where you can see which of the programs are highly complex versus simple. Delve into the areas that perhaps can't be automatically transformed because maybe they're in an unsupported language like, who knows, or maybe they're part of a packaged application that you're not allowed to transform. Also, we can look at things like clone code. So a lot of times in legacy applications, we have a high degree of clones where the same code has been, for a particular business calculation, has been copied and pasted all over the place, right? So as part of this transformation, we can go in and find that code and choose to transform that in a better way that reduces the clones and calls common routines, for example. So this is showing the original COBOL application in SIEM Evolve IT, where we have some COBOL programs, again, some generated by CA2E and some that have been coded by hand, accessing a database, and then containing several different copybooks. So it's a small example, but representative of what people are seeing in real life. Okay, we have a modeling API as part of our SIEM Evolve IT product that lets you model how you want your APIs to look, accessing the new Java code. Okay, so this is showing COBOL, but this is showing how we want the APIs to be modeled. Okay, with simple APIs around the calculations and the database access with the controller and a main container within that. And Kiyoshi will be showing that live in a few minutes. And again, just showing how, okay, once it's been transformed from the COBOL to Java, it can then be called by an API and called from within a standard React framework and get the same results that you did on the green screen. Yeah, I think I've set the stage then for Kiyoshi to take over. Okay, so I guess before that, we're going to do a poll question.
Yes, covered a lot of ground there, John. So my question out to the audience is, which technology components are you most interested in modernizing? And again, we have a lot of variety of options of 5. You can have more than one answer. So are you most interested in modernizing your application code or logic? How about your UI or UE areas of your customer interface, database, hardware, or is it adding microservices? So application code and logic, so overwhelmingly selected by 86% of all people. Then dropping down the UI and UE, still almost 2/3. Half the people are interested in database and adding microservices, and only 14% interested in modernizing hardware. I think that fall in line with some of the modernization techniques that we've seen. You get the best return on application code and logic and UI and UE. So back to you, John. Any surprises there?
Yeah, I was a little surprised about the hardware not only being 14%. I know a lot of people like to stay with IBM I, IBM Z for a long time, but other people are looking to move to the cloud, AWS, over time anyway. But yeah, I can see, yeah, that's certainly not the first step in modernization.
Correct.
I understand why that's slow.
Maybe the fact that you can look out at 10 years at the roadmap for hardware too, that gives people some peace of mind as well too. So
I'm here. I'm ready.
In our back room.
Take over.
Yeah, take it away.
Let's do live demo. So based on John's setup, So I'm gonna show, well, that's truth. So that's happened, okay? So just go to Refactoring by T. So this is same kind of diagram, which is live. You can move. So what I do show is first the server portion, so of course. So this has two program. One is calculation logic is in it, and then it's calling product information to retrieve from this view. And so this this program calling that the other program to obtain the program information and then obtain calculate it out. Okay, and then it's use the copybook. That's a setup to the transformation. Okay, so I'm gonna run actually on live for that transformation. Okay, go to the VM. Okay, so here's I'm gonna transform 4 source code today for COBOL to Java. I don't want too much, but so here's one of the program has some reading file that's like a get product, and it's using copybook that's have a data structure of that file, and also this other COBOL has, well, this is CN2E generated, but you see some logic of subtracting or multiply and etc. and some assignment, and yeah, nested if condition, etc. So those are calculation logic there. Okay, and also for the simple demo, so this is the other calculation, which is handwritten, pure handwritten, but yeah, that's a similar thing, but not doing anything, but just to display the result. So that's this one I can show compiling here, but the other two will expose as API and then consume much more modern way. So let's fire the conversion. So, well, it's starting actually converting, and then I put the empty. Sorry, this is not the folder. So this is generated folder. Okay, so this is right. So this is currently empty. It's working hard to reading, original COBOL. Okay, now the starting output something. I show you later, but while it's running, I'm gonna explain very lightly what's going on here. Okay. Okay. So it's a kind of three step. It's probably very obvious. So first, of course, it's load the source. So we have like a 4 program this case, and then it has associated with copybook. So the first step is load the COBOL source, and then if find the copy statement, loading copybook as like a compiler does, and then we create a complete set of COBOL source. Then we have tokenizing it. So tokenizing means just to find every single minimum component in the COBOL languages, like a move statement, like any of the field defined, any of the constant, any of the keyword, like a procedure division, etc. So those tokenize. Then once it's break down to the minimum component, it's create called AST. So AST is represent abstract syntax tree. So that time, it's now the source code become kind of syntax model. Okay, that's a pre-set up. And then after that, at the AST level, so abstract syntax level, there's something called simplifying or refactoring will happen. So simplify here means some example is like in any language provide doing same thing, but maybe maybe provide more than 2 or more than 3, more than 4 to achieve the same thing. So because we converting to Java, so just focus, just just convert those variation of different syntax to the same syntax. That makes the converter, final Java output easier. Also, sometimes like a COBOL, of course, you can assign like a group level assignment, like a data structure, high level, movement. But that's a really special concept. Of course, you can do in Java to like a class to class assignment, but let's break down to the individual move instead of one move. So that kind of is happened. And also paragraph, refactoring kind of paragraph in the COBOL, you may have 10 paragraph, and then you maybe write, perform paragraph A through paragraph X. Well, then it has like maybe nine paragraph exist between, but if that paragraph is not used individually, well, let's make it together, just a one big paragraph instead of 9 individual. And of course, we keep the comment of paragraph statement, so you don't lose that block. But it's much simplified to do that, merging paragraph, etc. Okay, so then as much as cleanup and things happen, then that ST is output as Java. So that's what this transform engine basic design architecture. Okay. Now I think it should be ready. Okay, so now, so you see some source here, that lots of Java code here. I don't want too much. I show you later, there's side by side. But first, yeah, I just want to run, compile, run the program. Okay, so okay, so let's compile program. Okay, it's already compiled, so it's too quick. So the Java class is compiled here, and it actually runs. So here's a display statement, and display company name, and then move total amount to total amount output, and then display total as something. So these two lines is corresponding COBOL version of that. If I show the Java version, so you see this, yeah, it's very simple, but the display is converted to system out print line, and then displaying company name, and then total. So of course, the calculation happened previously, but so that's what this looks like. Okay, now just make other program to show side by side using above IT. So I have already opened the source code. Okay, so to maximize. Okay, so I start the call statement. So this is a calculate order program, so which is in the diagram, this guy here. Okay, so this guy has calling the other program. Okay, so let's see how it's transformed. Okay, so here's a original COBOL statement, and then there's a input parameter assignment, and then call statement, and then user result is received. Received and here. Okay, then just the search thing. So this is converted as the way to call Java, and then here's a presetting parameter, and then receiving result. So that's how it's converted. So there, and also for the other one, as database access. So if I search read, so this is a COBOL read statement to read this logical file or view. Well, there's a lots of magic happening in the COBOL, of course, because this information come from copybook, which is come from actual logical file. But this RAM line does a lot of things behind the thing. But in the Java, it's not same. So we need to do. Okay, we need to convert that simple read as SQL select. And then you see that the column name is listed and the from table name and then where condition, that's a single for each kind of. So it's a parameter key field equal question mark and the order. And also, because it's a single fetch, we put the first one row only. So it's a little better than if we find lots of data, which probably this case shouldn't happen because this is primary key, but this one helped to only return the one row. Okay, and the other stuff is, yeah, the calculation code. So back to the first COBOL calculation. So let's say, what's the total? Okay, so this is a total calculation area. And okay, so see that the good thing is, yeah, the comment is kind of preserved. So you see the same comment. So that's what you can find relatively easily side by side. Of course, it's different syntax. So first it's multiply something of something, and then result to set. So here in the Java version is assignment, equal assignment. So that's already changed the sequence of field and also, of course, name of field as well. But this is Java multiply and yeah, the multiply B and then store the result to here. And if conditions is here, so something is greater than 0, and then that's same as the, yeah, well, the other way too, but yeah. Okay, and in subtract multiply, you can see something very obvious, and then you see subtract multiply. Well, in this case, Java and the COBOL has same word to the calculation, but maybe a different language maybe use different way. Well, of course, the Java side, it's everything become big decimal, which if you know Java or any those languages, you cannot use double, you cannot use float for the business calculation because rounding happens. So every number except integer with any data with a decimal become a big decimal, which is like has to be this data type to avoid some natural rounding. Okay. Okay, so now let's see. Go by T. Okay, so that's the diagram. So now I want to show this API portion. Okay, so these three is now Java, but when you model, it really doesn't matter because this program become Java. But you can define, you can remodel or regrouping or whatever term you like. I decided this three program I want to expose as API. So that's why I picked these three and then define the interface definition, and then I put the post, get, verb, and then I wrap with the order controller and then this is just a placeholder of the main place. Okay, now if I go, it's already running. So I have order controller and then 3 methods is defined. If you want to see how it's done, I don't go too much because this is pure Java and Spring Boot thing. So here's an exposed layer. So this is what the user or what the consumer see. So you have get and get product and post and calculate and then post and some name. Okay, but then we focus these two. Okay, and then receiving something and then returning something, and then something is they're basically same as almost the COBOL input output parameter, but we can model that information. So it has product ID and the amount and the quantity. So we pass. Okay, so anyway, so that's defined and the order service. So we have this is a core part of the consuming backend of COBOL. So we just the same thing, set the parameter, and then this is the execution, and then returning. That's very simple, just wrapping the COBOL converted Java, which is this, and then just the passing and this receiving parameter, and then respond back as what the consumer can understand. And I run something quickly. So this is a get product. And then, so this is a called Swagger. So if you build Able API, this is kind of very handy self-document tool. So you don't need to write the document. This is just the outcome from the Java API hosting. Okay, so if I type product code and then execute, wait a minute, so then you get some result back. Okay, and the same for order product. So in this case, I pass the 2 parameter, and I just give 30, and then execute. And then so you get the return with similar information, but also you get the total price back. Okay. Now, well, this is a little difficult to use. Then we created a UI with React called JavaScript framework, one of the very common framework right now. So if I can do same thing, type 5, and then get product. So you get the product. So this is same thing happening. So it's calling that one from the web UI interface. And then just I put maybe 30 here, and then I get order. So you see that the calculation happened, and then discount is applied. Yes, so here like 30 multiply 5 is 150, and then if there's more than 100, and then take a 10% discount. So that's why $15 is off. So that's why this is not the hard code. So it can run the other product. So you see there's some different results. Okay. So yeah, that's my part of demo. Okay, and back to John.
Yes, Kiyoshi, thank you very much. So we have another audience poll question now. It's something that we use frequently in our webcasts. It's called Mint, where M means that you'd like to have a meeting, or you've got some code you want us to take a look at. I means that you want to introduce us to other members in your team or in your company. N means that you'd like to be put on a newsletter. We have a number of monthly newsletters that we publish. for modernization, transformation, RPA, test automation, so forth and so on. And then T means that you want us to talk to another group that may or may not be in your company or in your organization, but would benefit from having this kind of webcast. So show the audience they can choose one of those possible outcomes. So you want to meet, you want to introduce us to other people, you want to just be on the newsletter, product newsletter, or if you want us to talk to a different audience on this related subject.
So we have several questions out there already, and
Oh,
that was
cool.
last opportunity to type in any
Yeah.
questions like answered.
Good, we're doing well on time here, so John, let's dive right in on the questions. I see one that indicates that we've got a lot of micro-focused COBOL. Can your tool handle that?
Great question. Great question. So we are focused on IBM I COBOL and IBM Z COBOL, but we can handle microfocus as well as other dialects.
Mm-hmm.
So yeah, a lot of people their microfocus may not be happy with that long-term solution because they are still in COBOL, even though they may be running on a PC. We still have to have COBOL staff, and we can certainly help in that scenario.
Mm-hmm. Another question was, what does the pricing model look like?
Okay, good question. I think we had a related question that came up as well about runtimes and stuff.
Audience member, yeah, it was about the frameworks are proprietary, the libraries of frameworks for execution.
Yes, let me answer that in general. So I think one attractive thing about our transformation offering is that it is a one-time charge that we charge to transform in this per line of code, and it's a very competitive price model, in the pennies per line, cents per line. And then the question about the runtimes is also good, because I think a lot of people are concerned that they transform, and then for the next 20 years they have to be paying for various runtimes to just run the code. And we do not do that. We open source the code. So you get all the Java code that's required to execute the application. Now we do have a product, Single Ball IT, that we demonstrated that we think helps a great deal in the analysis of the COBOL, and even going forward into the Java, it helps with that. And we do have a subscription model for that, but it's not required to run your application. So hopefully that answers the question on that.
Well, good news. Sounds like there's not a vendor lock-in. Another question is that customers got sign-on or CA2E, and they're generating RPG inside that application. Can your tool handle that?
That's a great question. And yes, an answer is yes, we can. What we would do in that scenario is we would generate the model in COBOL and test that, but CA2E has a pretty good ability to generate both RPG and COBOL from the same model and get the same results. There are some adjustments required around execute user source, etc. But we found that we can take the TUI model, generate the COBOL, and then transform that along with the model source. So we look at both the model and the generated COBOL to produce a final result.
Mm-hmm. And that's all flavors of COBOL, of RPG?
Well, if we're talking about TUI generates either RPG 3 or RPG ILE. So it would certainly handle both flavors.
Okay.
Because we're looking at the model itself and not at the generated RPG. Great.
Hey, another customer indicates that, or prospect indicates that we're planning to stick with DB2 for the I, and can we do that? Can we stay with DB2 rather than going to Postgres?
Absolutely. I'd say 90% of the folks we come in contact with are remaining on the I for at least a period of time, and they're also remaining on DB2. And the reason is there may be a lot of other applications or reporting packages that are tied to that DB2. and that just not even feasible. If they want to move from DB2, it's not feasible in the short term. So yes, absolutely, you can stay on DB2, and most people do, at least for a period of transition.
Great. Kiyoshi, I got a question for you. Will this code run on Amazon Web Services or AWS?
You mean
I assume
converted to Java? Yeah, sure. Yeah, converted.
once it's converted to Java, will it run?
Yeah, it runs anywhere the JVM there. Yep.
Okay.
And
And
even
now
you can host that service too. Yeah, the Spring Boot API can be hosted as service. Yeah.
great.
On the cloud. Yeah.
Yes, exactly. Well, that seems to be where management executives are really focused on that, ending up in a hybrid cloud one day or the other. Another one, this is a simple question with probably not a very simple answer. What is the performance of Java versus COBOL once it's been compiled?
Well, that is a great question. And COBOL is highly optimized for speed of transactions, right. And it's certainly hard to match that the languages, but we found that with some caveats that if you have the same hardware and you have the same resources allocated to the database and to the processing as you do on the existing COBOL, you're going to get very similar performance. Mm-hmm. And there may be some refactoring of the SQL, because you're going from record-based access to SQL-based access, and sometimes there needs to be some tweaking, and there always has to be some tweaking and tuning. But we found again that in the end, you can get the same performance, equivalent performance from the transformed application.
Great. Those are all the questions that I see. If anything else has come up.
I see one more out here. Are reports also converted? Great question. Yeah, we have two mechanisms. I mean, some people use what's called, I don't know the name of it, the standard COBOL, old school COBOL reports, where it's the COBOL is writing to an output file that is formatted. Especially see that on the mainframe, or code that came originally from the mainframe, maybe running on the I, and that just runs out of the box to the file. Okay. The other mechanism is around using an IBM I DDS report definition. We do have a process to move that report definition into a JavaScript framework. It can then be outputted from that. So the answer is yes. There is some tweaking of the reports that would be required to go to the JavaScript framework, but largely would be a process to be automated. So good news there.
Mm-hmm. Great. I think that pretty much concludes our technical. Oh, some more coming in. Great. Great. Seems like when you get one, and then 2 or 3 people get the courage to ask another question.
So we're using commitment control on the application. Are you able to handle this? Yes. The question is yes. We do handle the transaction control automatically as part of the transformation. I think that might be the last one.
Great. Well, if you think of a question, you want coming
in.
Okay. For those of you who are still shy at the top of the hour, you can always send questions into info@cmfirstgroup.com too. Okay. So you're not left out.
Yeah, I definitely want to address the conversion phase. Is it possible to have more meaningful names? And thinking about the TUI automatic generated names, and that is a great question. And yes, okay, so we didn't talk too much about we talked a little bit about the transformation, but it is all rule-based. Okay, so we can transform names as part of a rule definition. And certainly, if you come from the CA2E, it'd be possible to get the model name and transform into that. Transform into something that would work in Java and SQL. using a dictionary. So yes, that is something that can be done as part of the transformation automatically. Okay. Okay, I think that is
Great.
it. All right.
Okay, well, I think that we'll end here a couple of minutes early, give 5 minutes back to our attendees. Thank you very much for all of you that attended. And we have some that did register. Everyone will get a copy within the next 2 or 3 days. We do a slightly edited version of just of the same presentation, and we'll get that back to everyone also too, because there's usually a lot of follow-on activity, especially given the nature of today's topic. So I want to thank our John Rhodes and Kiyoshi Terasawa, our basically technical presenters and demo people. And thank you to our audience, and everyone have a happy Halloween out there, and safe holiday for everyone. Goodbye now.
Goodbye.
Bye.